So today we're going to be talking about rate of reaction. There's a couple really important things that are going to be a part of this topic. And again, this is kind of the last bit of information for Unit 7.1, which is really exciting because it means we're almost done. So the first thing we really need to talk about is reaction pathways. So in the same way, if you're running and you come across a mountain, it's going to make your run a little bit more difficult. When it comes to chemical reactions, there are things that can make our reaction a little bit easier. But when it comes to our reaction pathways, we're going to see a lot of graphs. We're going to see a graph with our beautiful X and Y axis. We're going to see some that look like this. And we'll also see some that kind of look like this. And both of these, even though very similar, are pretty different. So over on the x-axis, this is just kind of the reaction happening, or you could say the time of the reaction, anything like that. It could be measured in seconds, minutes, hours, who knows. Our reactions happen a lot of different times. And then over on our y-axis, this is going to be the energy. And again, that's true for both of these graphs. So when we're looking on here, and we're going to focus with this one first. So there's a couple key points that I kind of want you to plot along with me. So the most important thing here is the energy. This is the really important portion of what's going on with this graph. So there's two key points you're going to see. It's going to be wherever you start, and you can go ahead and add kind of some dots along there, and kind of where you end. So these are the two most important parts of the reaction because this is going to tell you pretty much everything from beginning to end. So all the way at the very, very bottom for this one, to go from here, so again, this is even with our starting point, all the way up to the very, very, very crest, the highest point of this graph, this is the activation energy, or E subscript A. So this is the amount of energy that it takes for a reaction to happen at all. So if you were to climb up this mountain, let's say pushing a boulder or something like this, something big and heavy, it could be anything. We could imagine it's a school bus, who knows? It could be anything big. So if you're pushing it up, and you're pushing it up and pushing it up, and then you just stop right here, that boulder, bus, whatever, eventually is going to just roll back down. You didn't push it high enough for it to kind of fall to a proper place. But once you kind of reach this point, you can let that boulder go, and it's going to kind of naturally fall down. That's how gravity works. We've been experiencing it for quite a few years now. And so our reactions are kind of the same. Once you hit that activation energy, once you hit that point, it kind of naturally goes the way it should. It kind of naturally has that chemical reaction happening. And the same goes over here. So it's a little bit higher. The activation energy is a little bit smaller. So again, the activation energy is from the starting point up to the crest. So we see at 1, it's smaller than the other. So let's go ahead and write that down too. So E subscript A is the activation energy. And this is the energy from start to the crest, or the highest point. Awesome. The other important part with this graph, and I'll go ahead and use another color, is going to be the difference from beginning to end. So for instance, if we're looking at this first graph, we see this is where we started, and then this is where we ended. So for that one, this is going to be delta E. So delta E is our change in energy. And so this is really important because we're going to have two words, and hopefully you've heard them before. We're going to have either an exothermic reaction or an endothermic. And a good way to kind of differentiate between these two, exo is kind of like exit, so the energy is exiting whatever it's in, so that means it's releasing energy, while endo is like entering, so the energy is coming into it. So for instance, here we see from start to finish, whatever this is gained energy. So it took that energy in. So this graph would be considered endothermic. It took energy in. While over here, we see the start here. We can follow that line over, and we see that it goes down, or we're losing a certain amount of energy. That energy is being released. And so because of that, this graph is exothermic. Awesome. So these are the most important things when it comes to the reaction pathways. So you need to be able to identify the activation energy. So that's from the start to the crest. And then you need to be able to identify the delta E, or the change in energy, which would be the start to the finish. And again, pulling out those lines from the start and the finish, just kind of out into a nice horizontal dotted line is always a good idea, just so you can kind of identify these things just a little bit easier.